Hello everyone, my name is Justin Newhall and I run JN Railroad Media here on YouTube. Welcome to part 2 of my history on the Lima-Hamilton diesel locomotives. In part 1, I went over the development and production history of the Lima-Hamiltons, from the merger of the Lima Locomotive Works and General Machinery right through to the end of production of locomotives in Lima, Ohio. If you have not yet watched part 1, I highly recommend that you do so. It provides context for the material I will be covering today. In this part, I'll be going over the mechanical and electrical sides of these first generation diesels. I'll be covering the history and development of the prime movers, and I'll also be examining some of the other quirks and features of these fascinating locomotives. Fair warning, this video will be more on the technical side of things, so if you aren't terribly interested in the mechanical or technical side of things, you may skip this video. But if you're like me and like getting into the weeds on the details of how things work, then join me as we examine the Lima-Hamilton diesels, the diesels that could have been.
At the heart of any good locomotive is an excellent prime mover. Fortunately for Lima-Hamilton, they had one in the T89 SA 4-stroke diesel engine. The T89 SA started life as a product of Maschinen Fabrik Augsburg-Nürnberg, known by the trade name MAN in Germany, as an engine intended for power generation and marine use. This design was licensed by the General Machinery Corporation, and production began in 1936. These engines became known as, quote, Hamilton engines, and were named for the city they were produced in, Hamilton, Ohio. This original design featured 6 cylinders in an inline arrangement with 8 3/4 by 12-inch cylinders and was naturally aspirated. It was designated the 68 SA and produced 400 horsepower. This engine was produced from 1936 until the merger with the Lima Locomotive Works in 1949. In those 13 years, a total of 194 of these engines were produced, including 42 that were used to repower rail cars, and a further 4 for industrial switching locomotives. These engines were also used in power shovels, tugboats, naval minesweepers, and other marine applications. This may seem like rather limited production, but one must remember that General Machinery was also producing other diesel engines for various other applications. These engines came in both 2- and 4-cycle variants and ranged from 400 to 7,000 horsepower. So General Machinery was by no means tied to the success of the 68 SA engine. The reasons for the merger between General Machinery and the Lima Locomotive Works have already been covered in part 1, so if you want to hear about that, make sure that you go watch that video. Needless to say, the merger was completed in 1947 with the idea that the 68 SA could be adapted into a good locomotive prime mover. Modifications were made to the design, and the prime mover Lima-Hamilton came up with was excellent. The new Hamilton model T89 SA 8-cylinder and T69 SA 6-cylinder were more or less the same design as the old 68 SA, but now with the addition of a turbocharger. I have the manual for the T69 SA, so I'll talk about the 6-cylinder version of the engine. The T69 SA has been bored out to 9 by 12 inches, and burns diesel fuel at a compression ratio of 12.7 to 1. The engine idles at 350 RPM and is rated to operate at a maximum of 950 RPM. Later modifications on some locomotives allowed them to operate at 1000 RPM. Each cylinder has 2 intake and 2 exhaust valves located on the cylinder heads and activated by push rods. The turbocharger provides about 8 to 9 pounds of boost to the cylinders, and the 8-cylinder provides about 12 to 13 pounds of boost. The engine itself makes about 900 horsepower and puts out 750 horsepower at the wheels. The 8-cylinder in the LS1000 made about 1200 horsepower at the crank and 1000 at the wheels. The engine block is constructed of welded steel, and the crankshaft is constructed of a steel alloy that is drop forged and heat treated. The cylinder heads are made of mehanite iron. The cylinder linings are made of a, quote, special wear-resisting cast iron, end quote, and are wet-type removable sleeves. The pistons are oil-cooled and constructed from aluminum to reduce reciprocating mass. These Hamilton prime movers proved to be fairly reliable and plenty powerful for switching. As Cincinnati Union Terminal put it in a report sent back to Lima-Hamilton after some testing, quote, "We feel that the Lima-Hamilton switcher is a piece of machinery that the Lima-Hamilton Corporation has every right to be proud of, and one which, in our opinion, will give a very economical account of itself over a long period of time, if properly maintained in accord with the progressive maintenance instructions as issued by the builder." End quote. I spoke to several members of the Whitewater Valley Railroad about the Lima-Hamiltons and their experiences with maintaining them. Let's introduce them.
So, all right, I'm here at the Whitewater Valley Railroad. I'm with Tony. You want to introduce yourself?
Hi, my name is Tony Schwering. I've been a member here since 2019. I am a qualified brakeman. I'm a maintenance away engineer. I'm a student conductor, and I primarily work here in the shop. I do track work. I've been all underneath the hood of this thing, so yeah, probably more than I cared to sometimes. But
you know it better upside down than right side up, right?
It feels that way. Yes, absolutely.
My name's Travis Weller. I'm Superintendent of Operations here at the Whitewater Valley Railroad. I have been an active volunteer since 2005 when I was 15 years old. My father started volunteering here in 1980. I was born in 89, so I've been around the railroad my entire life. But once I was 15 years old, I took our class, started helping out in the shop, started helping out doing track work, and then when I became 18 years old, I started in train service.
We asked these volunteers to tell us a little bit more about what the Hamilton prime movers are like to work on and operate with.
The Hamilton diesel engine is a little bit on the unique side. Do you have any insight on that?
I know that they were designed, I believe, in the 30s to go in boats.
36, I believe, is when they were released.
And I do that. They're weldment blocks, so that easy to fix little issue. If you ever get like a small crack, you can just weld it up. You don't have to worry about all the cast issues. Inline, just having an inline engine is kind of what makes them unique. I know a lot of the early switchers did, but the ones that made it this far, a lot of them don't. A lot of people switch to V engines.
Yeah,
and an inline 8 is very uncommon. And there's not many. I don't know if there are many inline 8 Baldwins left, even.
I'd have to go looking.
I know their big one was a 6-cylinder market. And it's really cool that the Hamiltons with that higher RPM and they were a little more proven before they even put them in the locomotive. And so, and being an Ohio-built engine going into an Ohio-built locomotive, it was like a perfect match.
Yeah.
And they have the notch governors on them, the same almost identical woodwork governors to what the EMDs have. So you have that 8 power notch throttle. You don't have air throttles. You don't have infinity throttles, mechanical throttles. You got the power bands. It does what it wants to do. It puts out a certain horsepower at a certain notch, and that's what you get.
Yep.
Yeah.
I know you also work on the mechanical side of the railroad. Are there any quirks of working on the Limas from a mechanical standpoint?
Having worked on the 2 Limas and then worked on the other 3 locomotives that are in service, the center cab, the GE, the EMD SD10, and the Alco S1, I would say that the Limas are actually some of the easier locomotives to work on. Under the hood, they gave you a little more room to work than especially the Alco. The ease of being able to take the various pieces of the prime mover apart or to be able to access, the motors, generators. You have just a lot more room with the Limas than you do some of the other locomotives.
Well, and that kind of tracks with what I understand was Lima's kind of thinking on building locomotives, diesel locomotives, was to make them easy to service.
Correct. And, one of the things that didn't necessarily set Lima-Hamilton apart at the time when they were, manufacturing the locomotives was using, I guess, a lot of off-the-shelf or established parts. So, no, using an Elliott turbo, using a standard industrial oil cooler, a heat exchanger for the oil system, using, Michiana type oil filters, and, using Westinghouse gear for the motors and the generators, and essentially using, what they didn't have in-house, using off-the-shelf parts, really did lend itself to be, especially today, to be able to maintain those. We're still able to service and buy replacement parts for, the Elliott turbo. We're still able to, when we restored 709, we bought that same exact heat exchanger for the oil cooler right out of the catalog. We just called the company up that owned the rights at the time, and they still sold that unit. Mm-hmm. So there's still a lot of parts that are available because they went with off-the-shelf parts.
The air compressors are another one that they're still around.
Yep. And, what didn't necessarily set them apart at the time has really lent, to be able to keep maintaining them in preservation. And then, of course, when we acquired the other two Limas from Armco, and when Henry Rentschler, before the remains of Lima-Hamilton was tore down in Hamilton, he donated all of his store of parts in addition to all the parts we acquired from Armco. And we kind of joke around that we'll be able to keep the Limas running long after the Alco or the EMD just because we have such a store of parts, which is phenomenal. Without that, we wouldn't be able to maintain these locomotives, especially the prime movers.
Yes.
As you know, they're very unique, and it's just, there's not a whole lot of additional part stocks.
Yeah, and we're also in a good position because the only people that left in the world that know how to work on them are here.
Yes, yeah, it's, we work on the other locomotives, but our knowledge base truly is with these Lima-Hamiltons. And, if we need some outside contract work done on one of the other locomotives, it's easy to find someone who knows how to work on an EMD. It's a little bit harder when you say you got a Hamilton T69 SA that needs some work, and people are like, what?
Oh, yeah. Pardon me now?
But, in reality, these engines at the time were designed to be maintained and operated by someone with an 8th grade education. So if you can follow simple schematics, diagrams, and read the maintenance manuals, they really are, a bunch of simple systems put together in a complex box. Mm-hmm. But they are not hard to maintain or operate.
And I guess it's the same with a lot of diesels of this era. They're really pretty simple machines. They're not complex by any means.
Well, my understanding is the horsepower was measured a little differently on the Limas than it was on most other locomotives.
Yeah. The Lima always measured their horsepower at the wheels, essentially, compared to crank horsepower like most other companies.
So they're when they say 1,000 horsepower, you're really getting 1,000 horsepower.
Yeah, the crank horsepower is closer to 12 to 1,300 for 1,000 horse.
And what would that put the 1,200s at?
Probably 13, 14.
So the equivalent of essentially an F3, EMD F3, which is, what, 12 cylinders?
Yeah.
Yeah. It's kind of incredible how little they had to change to make that jump in horsepower.
And the pumps are the exact same. They just move them further.
It's incredible.
Yeah, so she has the fuel pump potential to do what a 1,200 can do. You could prorate these. We don't need it, though.
No. Do you think... if we weren't worried about breaking it, do you think it could be pushed for more?
Yeah, I mean, like I said, the pumps are there. Everything's pretty well the same. They just changed that one value. So I think a lot of thousands would have been, if Lima didn't have their struggles, would have been rebuilt to 1,200s because it's just a really quick and easy thing to do.
Absolutely. Just on the theoretical side, how much do you think they could have cranked them up to?
Not much more.
No.
The inline eights, they had crank issues when they were in freight service. That was one of the bigger, when you hear the unreliability problems of a Lima. When they early on they had that problem where they would break a crank or two.
Okay.
And then it kind of got that reputation, and it's kind of like Alco had with their 244s. Once you get that started,
absolutely.
It's hard to come back.
Yeah, absolutely.
But and now what we have, the ones that are left, that problem's not an issue, because if it was, it would have been dealt with by now. Like they'd have already fixed it.
Yeah.
Tony agreed to give us a tour of Armco 709, where we can get a good look at some of the quirks of the Hamilton T89 SA prime mover.
So here's the side of your block back here. You want to shine back in there?
Let's see. Okay.
There you go. That's your that is your governor.
Uh-huh.
And you see you got your fuel setting, which is how far it moves your rack in millimeters.
Okay.
And then that's your engine speed.
Interesting that it was done in millimeters.
Yes. So the setting for these is 19 millimeter. I believe the 1200 is 21.
Interesting.
Yeah. And there's just, you set this to 0. And then you adjust each of these by a turnbuckle. So each of these is for one cylinder.
Interesting. I'm curious about that governor being in millimeters, because the original engine design came from Germany.
Yeah.
I wonder if that's why it is. They just...
Germany in the 30s, millimeters, question mark.
Probably.
Yeah.
Germany in the 30s.
But EMDs also have the same woodwork governor. And that's something that's unique for, at least I think for the Limas, the Baldwins might know. I know the Alcos don't. Is just like the Alcos and Baldwins, you have one pump per cylinder, but the Limas are in line with every cylinder.
Okay.
The Alcos are all right next to each other.
Oh, interesting.
And then they run longer.
Interesting.
They run the lines out to the injectors.
Huh.
So these are all cam operated pumps.
Interesting.
Port and helix, just like the EMDs, but the EMDs uses the cam, and the pump is in the injector. And so the cam just pushes down on the injector.
Whereas
these, the pump, your cam pushes in on a plunger here. You can see this one's down, that one's up. And you can actually see inside that port cover that's off. You can see the plunger actually halfway up. Whereas this one, you can see a spring. So it actually will push up, compress the fuel. Then once the injector pops, it meters all that fuel out. And so you change your fuel metering by rotating the helix.
Interesting.
And here's your push tubes for your valves. So your push rods come down through here, and all your cams are down here in the bottom. And, which door do you want to go in? We'll go this one, because there's another fun surprise behind this door.
Okay.
So you can see up there, those are your shutter controls. That's that modern system. And then right here's everybody's favorite part, the turbocharger.
Yes. How big is the turbo, do you know?
Nope.
No.
10 inch.
Do you know PSI?
This one, notch 8, full load, you get about 10 PSI.
Not much.
Not much, but then when you look at the size of the intake pipe,
gigantic intake.
that is a lot of air.
Yes.
It may not be high pressure, but it is a lot of air.
It'd be chugging.
Mm-hmm. I mean, here's your intake into the turbo, and here's your manifold back out.
And so, yeah, for those of you who want to know, a turbo uses the exhaust air to shove more air essentially into the cylinder.
Yeah, the exhaust air spins, and that spins your intake impeller.
As opposed to a supercharger, which is directly driven by the
gear
engine.
driven.
Yes.
Unless you're talking about
or chain.
Unless you're talking about a turbo to EMD, which is both.
In addition to the prime movers, any good locomotive needs a strong electrical transmission system to transmit that power to the wheels. For the Lima-Hamiltons, this electrical transmission was provided by Westinghouse. The switchers were equipped with 4 sets of Model 362D traction motors and had a gear ratio of 14:68, giving a top speed of 60 miles per hour. These traction motors rode on General Steel Castings Type A switcher trucks using 40-inch wheels. There was an exception to this, however. When the Rock Island received its first order of 800 horsepower switchers in September 1950, they were delivered with the larger Type B trucks instead of the standard switcher Type A's. I couldn't find any direct evidence as to why they were ordered with the road trucks, but I suspect that the Rock Island intended to use them in local freight service out on the road which necessitated the better riding road trucks. All of the end cab switchers were equipped with a Westinghouse Model 499A generator. The New York Central's road switchers had the same traction motors and generators as the switchers, but had a gearing of 15 to 63 for a top speed of 75 miles per hour. They rode on General Steel castings Type B road trucks with 40-inch wheels. The Pennsylvania's transfer units were equipped with 6 sets of Model 370 traction motors with a gear ratio of 15 to 63, giving a top speed of 75 miles per hour. They rode on General Steel castings Type C 6-axle trucks, riding on 42-inch wheels. They had a pair of 499A generators instead of one because the transfer locomotives contained 2 prime movers. These traction motors had a continuous amp rating of 1,040 amps, but could be overloaded for short periods of time to achieve maximum pulling power when starting or accelerating a train. The maximum short-term rating was 1,440 amps for a maximum of 5 minutes. These generators, trucks, and traction motors were all industry standard and were more or less fully interchangeable with other locomotives available at the time. Both Baldwin and Fairbanks Morse used the same GSC trucks and Westinghouse electrical systems. This would allow simplified maintenance for any shop that knew how to work on these sets of trucks and electrical equipment. There were also some other benefits to using the Westinghouse electrical gear.
For the most part, there's not complex relays and really weird electronics.
One of the advantages of using the new kid on the block, so to say, the Westinghouse gear, was that really, they operate very similar to the way a road locomotive would at the time. You have your 8-notch electric over hydraulic, throttle and governor system. And, where the ALCO and the EMDs utilized what was called transition to be able to keep operating and pulling at speed, the Lima-Hamiltons did not. They were set up in a permanent series parallel orientation for their motors across the generator. And when they reached the peak of production for the generator for the series parallel, they utilized what was called a field shunt system. And the Limas have a 2-stage field shunt system for the field of the traction motors. And when it reached, I believe, 962 nominal volts in the traction system, it would then introduce a shunt into the field side, create that additional resistance to bring your voltage down and bring your amperage back up and allow you to keep pulling.
Mm-hmm.
Because of not having a defined transition, they operate very smoothly. They automatically, run their field shunts as needed, and so they're very easy and smooth pulling.
Mm-hmm.
The Westinghouse gear also provided ample tractive effort for starting trains. In fact, Lima-Hamiltons received a well-earned reputation for being prodigious pullers.
One story I know and this came from, I believe I was told it was at Armco, from engineers there, that these engines had so much starting tractive effort that, remember we mentioned that they were jumpy?
Oh, yeah.
They were set to be jumpy. If they weren't careful, they would pull that slack out and they'd snap knuckles clean. Just break them.
Whew.
Another good fun fact, and I don't know if you mentioned this in your video already, but these are still the highest tractive effort 4-axles ever built. Starting tractive effort. Still.
Good.
Even the latest EMD Jeeps were still lower starting tractive effort than the Limas.
You heard it here, folks. This beats GP38.
Mm-hmm.
That's impressive.
And GP60s.
And GP60s.
Yeah. Now, get up to speed and this thing runs out of horsepower.
Oh, yeah.
But yeah, starting track, and their short time ratings, all of that, way higher. Higher than the Baldwins by sometimes just a couple thousand or 1,000, but still higher.
Of course, all of these elements need to be combined on one frame for a locomotive. The frames and other accessories of the Lima-Hamilton diesels were built to an equally high standard as the prime movers and electrical equipment. The 750, 1,000, and later 1,200 horsepower switchers rode on all welded underframes measuring 47 feet, 10 inches long with a total wheelbase of 32 feet 6 inches. The total weight of these switchers came out to 248,360 pounds. The 1,200 horsepower road switchers were 57 feet long with a 40-foot 10-inch wheelbase. Interestingly, they actually weighed about 1,000 pounds less than the end cab switchers, weighing in at 247,500 pounds. The Pennsy transfer units were by far the largest locomotives produced by Lima-Hamilton, and in fact, were the largest diesel locomotives in the world in 1950. They were 79 feet long with a 61-foot, 3-inch wheelbase and weighed in at 365,530 pounds. The car bodies of these locomotives were made to be relatively easy to remove to make accessing the essential systems within relatively easy. There are a good number of good, wide hatches all over the locomotive, making routine maintenance much, much easier to handle. For the most part, Lima-Hamilton diesels were delivered with most of the same appliances and accessories. Almost all of the company's diesels carried Gardner-Denver Type WXO Model 9100 three-cylinder air compressors, which were the standard air compressor for a lot of first-generation diesels. The 750 horsepower switchers, delivered to Cincinnati Union Terminal, were the exception to this. They were delivered with 6-cylinder Gardner-Denver compressors that were used to quickly pump up strings of passenger cars for rapid movement around the passenger terminal. From what I've been able to gather, all of the diesels were delivered with Schedule 6 SL brake stands and self-lapping independent brakes. This was a holdover from the steam era and wasn't unusual in early diesel locomotives. I would assume that the production line at Lima just used what they had available to them. Tony had some more insight into the brake stands, cab layout, and other features available to the operator.
Let me take a look at that control stand for
Absolutely.
the people.
Let me trade you spots.
Sure.
That seat's not original, is it?
The seat is not original. Cool.
Yeah.
Is it
The original, well, we don't know if it's original. It might be.
Is it a
The
loco-
one that was in it when we started doing the restoration was bigger, and you couldn't turn it.
Oh,
It was
interesting.
so since it has this dual control stand here, like if you ever look in 25's cab, maybe we'll put that in there. Her heater sits here in 25, and this
Okay.
isn't here, and you got a bench seat.
Right.
And so since this is here, and the heater had to be back there, they moved this whole control stand kind of in, and kind of crunched the like this. You know, it's all just closer. See how close your knees are to the.
Oh yeah, absolutely. It is. You know, I'm 6'1", and my knees are against the control stand.
Yes, yes. Now imagine 6'5", 6'6", and
real big guy.
I'm not that tall. That's how tall Dad is. And then you have the other seats. The back was closer too, so you sat closer. And so that's part of the reason we switched those seats.
Interesting.
But yeah, here's your dual control stand. You got your independent gauge, and I believe this would have been another gauge of some sorts here.
Maybe main res or something.
Maybe, yeah, probably main res and something else. And you had your throttle, which
Yay!
does still.
It still clicks in.
You got your full 8 notches there. And the fun learning part of it, or what we learned about it, I guess, is you can be running on that side, and if someone pulls this throttle out 2 more notches, like say you're in notch 3, and you pull this one out to notch 5, it'll go to notch 5.
There is no disconnect.
So it's kind of fun when you're doing like a little training thing in the yard, and someone over there is going really slow, and you're like, you just throttle up, and they kind of start freaking out a little bit, and you're like, then they look over and see somebody sitting here giggling. Exactly, just like that. And then the independent's the same way. You can just throw some brake on at them.
Great for training.
Great,
Yeah.
yeah,
But,
right in the way for everything else.
Oh, absolutely.
just right in the way.
As a brakeman myself, having that second control stand is a pain in the neck because
Just when you got to walk through here.
yeah, there is no room.
Exactly.
No room. Yeah, because I don't know, if you guys know, a lot of switchers, they'll have one door that opens and one that is just a solid panel.
Yeah,
And it's
I think
usually
most locomotives, even the
yes.
modern road ones.
I know 39 is like that. 532 is like that.
It's kind of a standard.
But so one side does not open, and that's almost always the engineer's side, and the other side does. But if you have a dual control stand, things get messy.
There's one of your modifications we've done. That's your 12-volt system, which controls the newer shutter control.
Okay.
Your radio.
Yep.
Your GPS power.
You mean the radio and GPS aren't standard? What? Because that's what this is.
Oh, it also had a dual pulley up here. You'd have
interesting.
You had a horn rope that goes over to the. See? So you had a horn rope for that engine.
Oh, yeah,
that side
there.
too.
Which makes sense, but when you're...
Speaking of non-factory.
Yeah, not factory.
Let's switch that back to the actual horn instead of the auxiliary horn mount.
We have, because we have a few members that have horns, multiple.
And so, you know, if you come here and volunteer, you're an engineer, you can put your own horn on. As long as it meets decibel requirements. And, you can't bring a horn here that's not legal and run it on the main. But that's part of the valves. You know, if your horn has an issue mid-route, you just flip back and you go right back to the horn on the engine.
And currently she's equipped with a 3-chime, I know.
Yeah, Nathan M3, I think maybe even M3H. That's his exact question.
So it's a nice horn. And then 25 has that's the M3H, isn't it?
M3H, yeah. She's an M3 and 25. They're basically the same horn.
Just different tunings. So
and then you got your...
look here, yeah.
You got your... that's your... They call it intake manifold pressure. It's your boost gauge.
Okay.
And then you got your oil pressure. Then you have your brake gauges there, your main res, and your equalizing and train brake, or not train brake, but brake pipe. Down here's your temperature, and then there's supposed to be a hot engine light, low pressure light, which the wiring back in this panel for the lights and that is has yet to be gone through. Yeah,
so there's still a couple of things left.
We want to update the gauge lights.
That's fair.
Update them to 12 volt.
Be 12 volt. Make it easier.
Parts for them.
Well, and people that do classic cars do the same thing. You know, you go from a stupid 6-volt system and you put it in.
And it's supposed to have
12.
a wheel slip light.
Oh, interesting.
Wherever that went, you got to go by the old the old feel in here.
The seat of the pants.
That's right.
Now, an interesting thing for people to note is basically with any switcher of this period, no speedometers anywhere ever.
Yeah. Although technically, she's only 2 years newer and has a speedometer.
Oh, 532?
Yeah.
Although 532 is a road engine.
That's true.
Anyway.
But yeah.
Let's see.
Her headlight control's been moved. The factory position would have been up here.
Up here.
Like 25.
That's where it is with 25.
And that's what you know, something you learn really quickly here is 25 is factory.
Yeah.
709 is everything but factory.
Armco did lots.
Yeah, but she's just been, but it's funny because 25's passed through like 3 times as many hands as, we're second owners of this engine.
Yeah, which is kind of incredible.
And 25 has been through 2, maybe 3 kind of unknown. There might have been some middlemen somewhere.
Probably. Yeah, I'm sure she went through a couple of equipment dealers. And,
but yet she still maintained all of her originality.
Yeah. Yeah. Let's see. The other thing to note about the headlight is it was up here in steam too. So they literally, with a lot of the stuff in these Limas, they did not change it from steam if they didn't have to.
Well, they were steam builders. You know, this was on the shelf. That was on the shelf.
Yeah.
Just throw it in the diesel.
You know, I'm sure you could have found the same headlight switch in an Allegheny. Would have been the same.
That was just a standard.
Yep.
Standard switch.
Let's see. You got all your electrics in there.
Yeah. So you got your start contacts, and then you have what do they call those? Engaging contacts? Question mark. Somewhere in there, and you got your voltage regulator here for your battery charging system. A couple fuses. You got the 12 volt fuse system with that power supply.
Essentially, those contactors are what, for throttle?
Your notches is controlled at the governor.
Okay.
These just pull in. These check for your drum. Down here, your reverse drum. Because I believe it's those, but it might be those. One of them's ground. The other one's. And they check if your drum is not in forward or reverse. It doesn't load the generator.
Ah, makes sense.
That's basically all it does. And so that's what it checks for.
Alrighty.
And so those won't pull in. And I mean, the contacts we're talking about are these little guys right here. There's just, you probably can't even pick them up on the camera. There's just little baby contacts there. And if those aren't touching or they're misaligned, you won't go anywhere. I've had a lot of people, it's how you get phone calls from people like on a Sunday afternoon.
Train broke.
It's not, it won't go in reverse. It won't go forward. And you're like, did you check the little baby buttons on the reverse drum?
You little buttons. And I, like you were saying earlier, you know, when the locomotive was first restored, there was a great big pops whenever you open and close the throttle. Contactors. Even now, there's still a good pop, and you can see a flash from behind that. You can hear it, and
you can see a flash.
Yes.
Another big reason that those, when we first started it too, these are your start contacts. These pull in and engage your battery voltage. Mm-hmm. And one will drop out when it fires, actually starts spinning over under some power, and the other one drops out when you let go of your button.
Okay. Okay.
And so you actually hear that, you'll hear the first click when it runs, and then you let off your button, hear the second click. And if you don't, something's stuck and you got to go figure it out.
And but
these are arc guards here. So they lessen the flash, quiet it down. And when we first got it running, because we were going through cleaning the pads and all that, those were all off. So that was part of the reason it was like
it's just
the other part was there was a lot of it.
Yes.
And there's your ammeters down there too. I don't know if you
it's right down there. Amp meter.
And then you also have these. Oh, that one's welded. This one welded? No. That's the back of your headlight. It's also how you get to the back of your number boards.
Oh, cool.
The side ones here get to your number boards. I believe this one's been cut. Open. Yeah, there's your number board light.
How about that? It's literally just a light bulb behind a panel. Mm-hmm. Well, again...
And if we can't get to them this way, you just take the number board off the front.
Yeah. Again, nothing that you don't have to do.
See how it's silver?
Yeah.
Reflective.
Helps
make them a little brighter. And then there's some more information here. There's a what is that? Like a inspection sheet from Armco.
That's cool.
Locomotive inspection sheet.
Very cool.
Yes.
When delivered, almost all of the end cab switchers were equipped with Leslie A125 horns. They were mounted in the middle of the front cab wall. As an aside, these have to be some of the most foul-sounding horns I have ever heard. Here are a few samples. There was an exception to this rule as well. When the New Haven ordered their switchers, they asked that they be equipped with air whistles, as was traditional in the New Haven. Lima-Hamilton happily obliged, mounting them on top of the long hood just forward of the cab. Interestingly, it appears as though they left the mounting bracket for the standard horn attached to the cab. In accordance with U.S. law, all of Lima-Hamilton's diesels were equipped with bells. They all seem to have been mounted behind the front pilot on the engineer's side, although I have not been able to confirm that. I was also unable to confirm what kind of bells they would have come equipped with. Currently, Armco 709 is equipped with a GE steel bell mounted in its original location behind the front pilot. Whitewater Valley Railroad 25, on the other end, has something of an interesting bell situation. As delivered, the 750 horsepower switchers had their bells mounted in the same place as the rest of the switchers, behind the front pilot on the engineer's side. However, soon after delivery, CUT modified all 6 of their new switchers to carry their bells in EMD-type brackets on top of the long hood near the front radiator. They also seem to have given them brass bells that have a rather unique sound to them. I suspect, but cannot confirm, that these bells might have come from the 060 steam switchers that were being retired and replaced by the diesels. I also suspect that this may have been done to make the bell more audible to people standing on station platforms at Cincinnati Union Terminal. Over their service lives, it seems that the Lima-Hamilton diesels were rarely modified, remaining in mostly factory condition for the majority of their careers.
Were there any major modifications that were made to the Limas over the years?
So, comparatively to a lot of locomotives in preservation, these Limas are pretty well as built. A lot of the modifications that were done to them were modifications that were shared amongst most of the Limas between different railroads. These engines were equipped with what was called a sequence converter, which was an additional piece of tech between the throttle and the governor that helped modulate engine output relative to throttle notch. And that tended to be a common piece that was bypassed, and both of our engines have had that modification made. One of the other modifications, which I spoke about earlier, was the removal of the intake air intercooler, just to prevent freeze damage. But other than that, they're really in a pretty original state as they operate here at the Whitewater.
Yeah, so as far as like the freight railroads or railroads before us, Armco didn't do a lot with them. They added on the Lincoln pin pocket for those ingot cars. They had the side hand rails. They were rough with them. Number boards would go missing / get rammed off, whatever. The stack was leaning when we got it because it was one of those things that if it doesn't fit in the building, you make it fit. You just kind of it'll go.
Take a hammer and
side window shades get bent. I mean, that's where 320's cab side is caved in from getting hit sideswiped. They would go on the side where the builder's plates go, and that's where your brake valves are, and you didn't want to bring them up from underneath like we do now because that's difficult. So they just cut a window in the side and put a hinge door on it. Things like that. Those are all little things we had to do to bring it back to as built.
A pair of the New York Central's Lima-Hamilton road switchers were repowered with EMD 567 prime movers sometime in the late 1960s, serving as terminal switchers in Philadelphia well into the Penn Central era. As far as I know, these were the only two Lima-Hamiltons that were ever repowered with new prime movers. Looking back on the Lima-Hamilton diesels, it's clear that a lot of thought was put into the design and components of these locomotives. Great care was put into their design, construction, and technical support once in service, despite the fact that they were only sold for 3 years. This care really shows through with the quality of the product that Lima-Hamilton produced. LH was able to maintain its reputation as the, quote, Swiss watchmaker of locomotives, end quote. They're powerful, reliable, and easy to maintain, even 74 years after the end of diesel production in Lima, Ohio. Coming up in Part 3, we'll be discussing the service lives and preservation of these rare birds. You won't want to miss out on it, so make sure you stick around for it.
Thank you so much for watching this video. If you enjoyed it, please consider liking and subscribing to my channel. It really helps the channel grow. I want to give a special huge shout out to the folks at the Whitewater Valley Railroad whose help and dedication to preserving the Lima-Hamiltons and other historic equipment has been instrumental in the making of these videos. If you get a chance, you should come down and visit us. We're located right here in Connersville, Indiana, about an hour and a half northwest of Cincinnati and an hour and a half southeast of Indianapolis. We have 2 Lima-Hamiltons operating and a third on the property. If you're interested in helping me grow as a creator, please consider becoming a channel member. It would really help me fund the creation of future videos. If there's a topic that you'd like to see me cover, let me know down in the comments below. I'm always happy to take new suggestions. There's always more to learn. Thank you so much for watching, and take care.
For your movement, your crossing will be protected. Amen.